All right, 8-2, day 2, moving on with trig. 8-2, day 2. We'll be doing some story problems with those trig ratios. And like I said, I'm going to write that SOHCAHTOA across the top of my notes. I would do the same thing on your homework. And all we have today are examples. So if you have a right triangle and you know one angle and one side, you'll be able to solve any piece of that triangle, which you're going to see now. So it's just a set of examples today. I'm going to move the triangle around a little bit so things aren't quite as obvious. But there's my right angle. I'm going to give you a 57-degree angle here, missing side here, and a 17 over here. Now, what you have to do with these is you have to stand on the angle that's given. So here's your reference. And then you have to label the two sides that we're working with, the unknown side and then the one that's given. So the unknown, obviously, that's going to be the hypotenuse because that's across from the 90, so I'm going to put a little h there for hypotenuse. And then this is one of the legs. Is this the adjacent leg or the opposite leg? And I know I'm standing up here. So because it's across from me, I know that it is the opposite leg. So now I'm looking for which one of these three ratios works with the hypotenuse and the opposite, and I can see it right here. So now I know I have to set up a sine problem. So the sine, and you always need the angle that you're standing at next to this. So that's the 57 degrees. And I have to set it up, whatever's on the opposite, over the hypotenuse. The opposite is the 17, and the hypotenuse is the x. And now we've just got to solve for x. Well, here's my trick for this. When I have a proportion on this side and then not a fraction over here, I just like to put 1 underneath it. And then it's cross products. And don't pick up a calculator till we're all the way at the very end. So when I do cross products, 1 times 17 is 17. And I know cross products are equal, so now I've got x multiplied by the sine of 57. Now I want to solve for x, so I want to get rid of this sine of 57. Well, we just do the opposite of the operation here. If it's being multiplied, we're going to be dividing by the sine of 57 on both sides. Those cancel over there. Now we pick up a calculator and type in exactly what we have. We want the 17, you can see it, divided by the sine of 57. Enter. And I think they rounded to the nearest hundredth. So 20.27 will be our answer. Okay, some of you might have, I forgot to mention yesterday, some of you might have a calculator that requires you to put the angle in first and then the sine. The Apple, the scientific calculator that comes on the iPhones, it used to do that. I don't know if the brand new ones do or not, but it was not a great calculator. And you can always download a free scientific one to your phone, and it'll do everything we need here. So hopefully you don't have any issues with that. Let's try another one. Another triangle, let's go. 90-degree angle there. 42 degrees here. Missing side here. And 9.5 here. So again, you always stand yourself at the given angle. There's my reference. You have to decide what two sides these are, either adjacent, opposite, or hypotenuse. Then you pick your trig function, then you set up your ratio. So, I always like to find the hypotenuse first to see if I'm working with that. Here's the 90. That does make this the hypotenuse again. The two legs are here. If I'm standing on the 42, this x is the adjacent leg. So I've got the a and the h. So if you look at the top of your notes, a and h are both involved in cosine. So we are going to set up a cosine problem. So cosine, angle comes next, and then it has to be the adjacent on top, hypotenuse on the bottom, in order. Adjacent is the x. Hypotenuse is the 9.5. And just like the first one, now it's a matter of just doing cross products. So the x gets multiplied by 1. And then here we're going to have 9.5 multiplied, that's my multiply sign, by cosine of 42. And now it's calculator. I'll use my phone calculator this time just to change it up. Calculator. 9.5 times the cosine of 42, 7.06. Let's go for another one. Right angle there. 12 missing side length and 18 degrees up here in this little corner here. So the 18 degrees is my reference. Stand on the known angle. Don't stand here because you don't know the angle measure. That's the whole point. Stand on the one you know. And now it's labeled these two sides appropriately. Well, again, I like to find the hypotenuse. The hypotenuse is over here. It's not involved at all. So I'm not even going to put the h down. I'm only using the two legs. So, looking across, there's my opposite leg. Here's my adjacent leg. So I'm to the two legs, looking at the top of the notes. Opposite and adjacent are involved with tangent, and it's the opposite on top of adjacent. So, tan 18 equals 12 over x, opposite over adjacent, put a 1 under, two proportions, cross products now. Doesn't matter which one I do first. 1 times 12 is 12. Then it's x multiplied by the tan of 18. Solving for x, I've got to divide by the tan of 18 to get x by itself. And now you pick up the calculator. 12 divided by the tan of 18, 36.93. Okay, moving into some story problems. What number am I on? 4. Let's see, we've got a wheelchair ramp. Let's see, wheelchair ramp to a doorway 1.2 feet above the ground. To a door that is 1.2 feet above the ground. It makes a 4.8 degree angle with the ground. What is the horizontal distance covered by the ramp? Covered and how long is the ramp? So 2 questions. So, when it's a story problem, you've got to get yourself a picture. Chances are you are going for a right triangle. So, let's say here's our house. Oh, I'm going to mess up a little house here. Here's my doorway. And then here's the ground. And what it's telling me is this doorway is 1.2 feet above the ground. So that side right there is 1.2 feet. I've got a ramp up to the doorway that starts out here on the ground. So you can see our right triangle is right here. We got the ground, the distance up to the door, and then the actual ramp itself is here. And they're telling us that it makes a 4.8 degree angle with the ground. So the ramp touches the ground down here, so that angle in there is 4.8 degrees. Okay, and my questions, 2 questions were, what is the horizontal distance covered by the ramp? Remember, horizontal is left to right. That horizontal distance is the distance along the ground here. And then how long is the ramp? The actual ramp is what the wheelchair or the person would walk up. That's this here. I'll call that one Y. So we have 2 unknowns. So we'll have to set up 2 problems. And our reference is the 4.8 degrees. Let's find that horizontal distance first. So we're not going to have 2 unknowns, so we'll do this one. So identifying the sides. If I'm standing here, the hypotenuse is up there. I'm not using it. That means this is the adjacent leg here. And the opposite leg is the 1.2. And opposite and adjacent, that's the TOA. So that's tangent. So a tangent is going to get us that horizontal distance. So the tangent of 4.8 equals, and it has to be, it's TOA. So it's opposite on top of adjacent, so 1.2 over x. Make that side a proportion, and now cross products. 1 gets multiplied by 1.2. X gets multiplied by the tan of 4.8. That's a times sign. And now just 1 step to solve. We've got to divide by the tan of 4.8. Opposite of multiply. So 1.2 divided by the tan of 4.8. So it's covering just over 14 feet along the ground, 14.29 feet. And then the second question asked us to find the length of the ramp. Now I've got options. Because I know this side length, I can use multiple trig functions. But I'm going to stick with using the opposite, the given 1.2. And then what I'm looking for now, because the ramp is across from the 90, that's the hypotenuse. I'm not going to use this side. So opposite and hypotenuse, that's the So that's a sine function. So we will set up a sine problem. So the sine, standing at 4.8 degrees, is opposite is the 1.2. That's what's across from me. And the hypotenuse is the y. So very much like the last algebra here, where we do cross products, 1.2 equals y multiplied by the sine of 4.8. I can retype that, change that to sine. 14.34. So just a smidge longer than that horizontal distance on the ground because that angle's so small. Okay, one more challenging problem and we'll call it good. Let's see. I'm going to give you a rectangle, And here's what we know about the rectangle. The short side is going to be 63 feet. The long side is missing. And we know if we draw in the diagonal, the angle made with the diagonal in the bottom side is 32 degrees. I am going to ask you to find the perimeter and area of the rectangle. Okay, so perimeter, remember, since you add up the outside edges. Well, you know this side's 63, so you know the other side's 63. So our goal now is to find the long side of this triangle so we can add two of those on to those two and get the perimeter. So trig is going to help us. So we are going to ignore the top triangle there. Completely ignore this. We're going to stand at this 32-degree angle and identify these two sides just like we've been doing. That puts this one as the opposite leg and this one as the adjacent leg because the hypotenuse is the diagonal. So opposite and adjacent. So TOA is going to help us figure out that missing side. So that's tan. So tan 32. Opposite is the 63. Over the adjacent is the missing. Cross products. 63 equals x multiplied by the tan of 32. Do a little dividing. Okay. So 63 divided by the tan of 32. That long side is 100.82. So what we just found was the other side of the rectangle. And now to answer the questions for perimeter and area. Perimeter, I've got two 63s, plus I've got two of the 100.82s, and that's just a calculator problem. Times 63 plus 2 times 100.82. Total perimeter is 327.64. And then the area of a rectangle, if you remember, is just length times width. So our length and width are 100.82 multiplied by 63. So 100.82 multiplied by 63. 6,351.66 square feet. And this one was a total length of feet. And I think we will leave it there. Done with that. Okay, nice job.